So what I want to show you guys is that yesterday we did the math modeling. I was going to give you guys, we'll still have to do a worksheet, but I'm going to wait until we have the data. So yesterday we did the roller coaster thing, and then I still have to get the data for that. So today we're going to do 2.7, which is on page 248. And we'll do the examples of that. So we're solving equations in one variable. However, these equations are not always easy to solve. They're kind of complicated. So we've been making it easy for you guys up until this point when it comes to solving these equations. Now it gets real. We're gonna do some complicated equations. So for example number 1 from 2.7. We're asked to solve x plus 3 over x equals 4, okay? And what is it that we don't like about this?
It's fraction.
The fraction, right? So the fraction is kind of the problem. So what I could do, watch this, this is kind of a neat thing. Let's add, our goal is to get x by itself and all the other stuff on the other side. So that means my ultimate goal is to get one x on one side of the equal sign and all the other stuff. And right now I have 2 x's, right? So if I want to ever have some sort of hope of combining those x's, what I need to do is find a common denominator. Well, this is like x over 1, and this is x. Now it doesn't matter how you look at it. I can find the common denominator, or I can multiply everything by x. Doesn't matter. We'll end up with the same thing. So I'm just going to multiply everything by x, because that's one technique we could use. We could use the common denominator technique, or another technique we could use is we could take the denominator and multiply it by everything in the equation. Right? So now if I do that, that gives me x squared. This x will cancel with this x, so it'll be plus 3 is equal to 4x. Well, now that looks like a quadratic equation. I could probably solve that. So if I rewrite this, I get x squared minus 4x plus 3 is equal to 0. So then over here, I don't know, do you think that's factorable? Well, I know that x times x gives me x squared. What two things can I multiply to get positive 3, but when I add them up, I get negative 4, right? These two terms here and here have to add up to equal negative 4x. How could I do that? Well, 3 is a Yeah, 3 is a prime number, so the factors are just 1 and 3, but if I make them both negative, I get the positive 3 here, and then I get negative 1x, and then negative 3x, okay? Does that make sense? So then this factors to x minus 1 times x minus 3 equals 0, or x minus 1 equals 0, x minus 3 equals 0, so x equals 1 or x equals 3. That's it. Now how could I verify that? What are these solutions? They're the zeros, which means what graphically? I heard somebody say graph it, and you're right, we are going to graph it in a second. But what does this mean? Say that again. Yeah, they're the x-intercepts, right? So what I'm going to do is I'm going to graph this real quick and see what we get. So to do the equals 4 thing, I can't do. So I'm going to have to graph this. So hopefully I didn't make any mathematical, let me point this out. Hopefully I didn't make any mathematical errors to get to this point. If I did, I'm not really double checking a whole lot. There's another way to do it too, and I'll show you in a second. But first thing that we want to do is well, there's lots of ways I could graph this. So I'm going to explore all of them, all right? So the first thing that we could do is I'm going to say x squared minus 4x plus 3. And then we're looking for the 0. So if I graph that bad boy, it should cross at 1 and at 3. What do you think? Crosses right here at 1, crosses right here at 3. So far, so good. Now, how could I verify that I didn't make any mistakes? In other words, how can I verify that I didn't make any mistakes from here to here? Well, here's another, I don't know if you guys remember this or not, another thing that we could do is we could graph the left-hand side of the equation, which was originally x plus 3 divided by x, right? And then the right-hand side of the equal sign, which was 4. That was the original equation that was given to us. Now, when I graph both of those, I'm looking for where those two cross. Where do they intercept? Where do they intersect, I mean? Where do those two intersect at? Well, when x equals 1 and x equals 3. That's no accident. Huh? You like that? Huh? That was for you. Okay? Any questions? Okay, good.